Now we're going to be looking at how to divide and also rationalize radicals. So just as a reminder, just like with multiplying, when you divide, you just have to have the same index. So as long as we have the same index, we can write the two radicals underneath the same radical sign and just divide what's underneath. Now in this problem here, we both have square roots, which means I can go ahead and rewrite this problem as the square root, one big square root, of 48x cubed over 3xy squared. So now we just follow all of our exponent rules whenever we divide. Now 48 divided by 3 is just going to leave me with 16 on top. Now x cubed divided by x, remember you subtract the exponents, I get x squared on top, and then I'm going to be left with a y squared on bottom. So now we can go ahead and simplify. Now we can break this apart again and simplify both of these radicals. Now on the top here, the square root of 16, I can rewrite that as the square root of 4 squared, and then I have x squared, and on the bottom, square root of y squared. So anything to the second power will hop out. So the 4 will hop out, the x will hop out, and the y will hop out. So I'm going to be left with 4x over y, and that is in simplest form. Both of these are cube roots, so let's go ahead and write them underneath one radical. So then we just divide the coefficients and we use our exponent rules for all the variables. So I'm left with the cube root of 8. Now x cubed divided by x to the 4th, I leave an x on the bottom, and then y squared divided by y, I get a y on the top. So now we can break this apart again to simplify. And the cube root of 8 on the top here, well, we know that will hop out and give me a 2. So I'll get 2 times the cube root of y over the cube root of x. Normally, we do not like any radicals in the denominator of a fraction, so we must rationalize. Now, for square roots, this is pretty easy, especially if the denominator is a monomial. So we just multiply top and bottom by whatever our current denominator is. Now, since both of these are square roots, you just multiply the radicands. And if you're multiplying correctly, the bottom should give you perfect squares that will eliminate the radical. So on the bottom here, 64 will hop out and become an 8. X will hop out. So I'll be left with the square root of 1000x all over 8x. Now, you still need to simplify the numerator. So 1,000 will break up into 100 times 10. So the 100 will come out and give me a 10. And I'll be left with the 10 times the square root of 10x divided by 8x. And now we are in simplest form. We have to approach it differently whenever we do not have square roots. So for any higher roots, like cube roots or fourth roots, we must multiply the top and bottom by whatever would make it a perfect nth root. Now here in this problem, I currently have 1 5 and 2 y's, right? Y squared. So to make the bottom a perfect cube, I would need 2 more 5, so that's 5 squared, and I would need 1 more y. So since I multiplied the bottom by that, I have to multiply the top by the same thing. Multiplying, you multiply the radicands. So I'm going to be left with 7 times 5 squared, xy, all over. Multiplying the bottom radicands, you get 5 times 5 squared, which is 5 cubed, y squared times y, which is y cubed. Now, if we multiply by the correct thing, here we have 5 to the 3rd power, so that will hop out. Y to the 3rd power, so that will hop out. Now, on top, we simplify. 25 times 7 leaves me with 175 xy. And on the bottom, we just have 5y. Now, before we finish, we have to make sure that the top is completely simplified. 175 is 5 times 35. 35 is 5 times 7. So nothing is in a group of 3. So this cannot be simplified any further. So that is my final answer. Whenever our denominator is not a monomial, to rationalize, you must multiply by the conjugate. So remember, conjugate just means change the sign of only the radical term. So for this problem here, we're going to multiply top and bottom by 3 plus the square root of 6. Make sure you put it in parentheses so you remember to double distribute. So on the top, we're going to get 12x plus 4x times the radical 6 all over 9 plus 3 radical 6. Negative square root of 6 times 3 gives me negative 3 square root of 6. And then we get negative square root of 36. Now we have to combine like terms. Now these guys go away, and the square root of 36 becomes a 6. So on the top, we cannot simplify. But on the bottom, if we multiplied by the correct conjugate, we're just left with no radicals. So I just have 9 minus 6. So don't forget the sign of whatever that term is. And in this case, it's subtraction. And then that will be my final answer. For the following problems, I want you to simplify and rationalize all denominators.